Group 5 with Rashmi Kulkarni, Angie Mombram, and Ryan Shelton. And we're going to discuss our project, which looked at predicting stock values. In this project, we use different statistical models to analyze stock data with respect to itself, the NASDAQ, and economic indicators, such as interest rates and inflation rates. The purpose of the project was to see which model best predicts stock prices and returns. Our hypothesis is that there would be one single model that can give us accurate predictions for stock prices and gains. For the analysis, we used 12 stocks: Apple, which has a ticker symbol AAPL, Amazon, which is shown as AMZN, Alibaba, BABA, Microsoft, MSFT, Netflix, NFLX, Anthem, which is ANTM, Humana, HUM, Aetna, which is AET, United Healthcare, UNH, Facebook, which is FB, and Twitter, which has a stock ticker of TWTR. We also added NASDAQ data, US Treasury interest rates, and US inflation rates to the data set. We retrieved all the stock data from Yahoo Finance, and economic data came from the Federal Reserve Economic Database, known as FRED. We also used a multiple regression model, a logistic regression model, ARIMA, and an auto-ARIMA model to predict stock prices and gains. Now to discuss the methodology, I'll turn it over to Angie.
Thank you, Ryan. For this project, we used the quant mode package in RStudios for our analysis. We were able to get the Yahoo Finance data directly into RStudio, and after we retrieved the data, we created a CSV file. The first thing that we did was use a multi-regression model, and we used that to analyze the relationship between each of the 12 stocks with the NASDAQ index, interest rates, and inflation. We created a training data set and analyzed the mean square error for the testing data set to figure out how accurate our prediction would be. Through this analysis, we were able to find which of these covariates, which is NASDAQ, interest rate, and inflation, were statistically significant in predicting future prices. Also, we found how much of the stock prices can be explained through this model through R-squared values and mean squared errors. Subsequently, we use logistic regression to calculate the accuracy of the prediction of the direction of the stock prices with respect to the NASDAQ index, interest rate, and inflation rates. For this, we created a dummy variable for each of the stock in our data set. Then we created a training set and a testing set. By using this model, we could analyze the accuracy of the prediction for the upward trend in the stock. Lastly, we used time series ARIMA models to explain gains based on the previous day closing price. We created an ARIMA algorithm which calculated the lag in moving average that provides us with the best prediction accuracy for each stock. To exceed the probability of chance, we need the accuracy to be at least greater than 50%. We compared the accuracy of each model with respect to each of the 12 stocks to see if one model was better than the other. The results of each stock will be explained in the results section. And Rashmi will go over our results.
Thank you, Angie. So in the multiple regression model, we conducted a regression analysis of each stock with the NASDAQ, the interest rates, the inflation rates, to find which variable were significant and which were not. The R-square values informed us of how much of the data can be explained by this model. And for most stock, the R-square value was about 80%, which is considered pretty good. We also divided the data set into training data set and a testing data set and found out the mean square of errors for the test sample. Thus, the model gives us how much of a difference can we expect between the predicted value and the actual value of the stock. As you see in our results, the value for Amazon is about off by $123 versus it's off only by $1 for Twitter. This means that we can be more certain about the predicted value of the Twitter stock than we can be about the Amazon stock. Next slide, please. In the logistic regression model, we observed greater than 50% accuracy for all the 12 stocks, which means that the model has better chance of predicting whether the stock prices will go up or will go down based on just mere chance, better than a mere chance. We also concluded that not all economic indicators were statistically significant, as you can see from our table, when we were considering these changes in prices. Moreover, the AIC and the null deviance, the residual deviance, were also relatively high for this model. You can look at the table for more details. The ARIMA model, which is a time series model that was used to see the effect of how the stock prices from the previous day affects the closing stock prices of the next day. By using an ARIMA model, we were able to calculate which was the best model to give us the most accurate prediction. If we can predict some stocks, stock prices with 50% accuracy, we were better than guessing the price by chance. However, if we can get a higher accuracy level, we can be more certain about the prediction of our model. So as per the output of this model, we see that this model is not very accurate for most of the stocks. And for the stocks like Facebook, Google, and Apple, it's barely crossing 50%. From the above results, we can predict, say, the Twitter stock with 42% accuracy. But with logistic model, we could predict the accuracy to be 54% for the same Twitter stock. So when using the regression model, we knew that the stock prices of Twitter would have a mean error of 1.6, which means that the actual price of the stock would be within $1 difference of the predicted price. So by combining all these three models, we could increase the chance of predicting the trend, the price of the stock based on these different factors. In case of Google, the ARIMA model has a better prediction than the logistic model. And similarly, we can see the price difference between what the regression model is predicting versus the ARIMA model. And we can try to make our predictions more accurate based on the combination of all these three models. So we can apply similar strategies to all the 12 stocks in the data set and see which model works better, or does a combination of these models work better. For our conclusion section, I would hand it over to Ryan again. Thank you.
Thank you, Rashmi. So initially, we believed we could create a single model that would predict stock prices accurately, but after creating 3 different models, we concluded there is no single model that accurately predicts stock prices for all 12 stocks. Each stock had a different model that explained its price better than the other 2. The stock data is dynamic, and there may be more research required to find better ways to optimize the predictions. We would like to take this research further to see how stocks in the same category affect each other's prices and determine if we're able to predict a stock's price from the previous closing price of a competitor.